in listen-only mode.
Good afternoon, everyone, and welcome to the Society of Wetland Scientists July webinar. My name is Bianca Wenzel, and I'm your moderator. We have a great turnout for today's event, and I'm looking forward to announcing the topic and presenter for our August webinar later in the program. The SWS webinar program has proven to be a great addition to our membership benefits list. I'm excited about the opportunity to provide our members with more great educational content as we move through the rest of the year. The general format of today's webinar will be a 40 to 45-minute presentation by our speaker, followed by approximately 15 minutes of questions from the participants. Before we get started, I'd like to go over a few housekeeping announcements. Just to familiarize you with the GoToMeeting screens, there is an attendee control panel where you can control the audio for the webinar by using either your telephone or your mic and speakers. At any time during the presentation, you can type your questions into the questions pane. Our presenter will be answering questions at the end of his presentation. I want to note that all attendee phone lines are on mute to cut out background noises and distractions. This webinar is being recorded, and you'll receive a link to the recording following the webinar. We also ask that you take a moment to complete the evaluation survey that will pop up at the end of the webinar. This will help us to plan future events. If you would like a copy of today's slides, please find a PDF copy in the handout section of the control pane. Please use the hashtag SWSwebinar to tweet about today's webinar. We love seeing what you have to say about the event. All right, so let's test the questions pane and at the same time get a little demographic information by having everyone type the state or country you are participating from and how many people are viewing the webinar with you. So far, we've got Texas, Colorado, Nova Scotia, Peru, Louisiana, New Mexico. People seem to be from all around, and we'll record this as well. There is just a quick question I'll address. Someone is saying that their control panel says they're muted by an organizer, and that is everyone should be muted so that we don't hear the background noise. If you have a question during the webinar, please type it in this questions pane and we'll try to get to it. Okay, so with these logistics out of the way, let's get started with our webinar. It is my pleasure to welcome today's presenter, Jan Vimazal. Jan graduated from the University of Chemistry and Technology, Prague, where he also received his PhD degree. Currently, he is a professor in the Environmental Sciences Department at the Czech University of Life Sciences, Prague. Jan is also an adjunct associate professor at Duke University's Wetland Center in Durham, North Carolina. His major research is focused on wastewater treatment in constructed wetlands and nutrient cycling in natural wetlands. He has authored more than 100 research papers in peer-reviewed journals, edited 10 books, and authored 2 monographs. Jan is a member of editorial boards of several international journals, and he is the editor-in-chief of the journal Ecological Engineering. From 2009 to 2012, he was a chair of the IWA Specialized Group on Wetland System for Water Pollution Control, and he is a past president of the SWS Europe chapter. Welcome, Jan. I'll turn things over to you now.
Thank you very much, Bianca, for this nice introduction, and good afternoon. And for those who are in different time zones, also good evening and maybe good morning. So, as Bianca already indicated, I will be talking today about various types of constructed wetlands for wastewater treatment. Is it going to be a brief introduction to different types and also different types of wastewaters which can be treated in constructed wetlands? First of all, we have to realize that constructed wetlands are systems which are using natural processes which occur in the natural wetlands. This is a great advantage because we can take our knowledge from natural wetlands and use it for constructed wetlands. For example, as compared to most typical wastewater treatment system activated sludge, this is not a natural system, so we have to create some special conditions. In general, there are many ways how we can classify constructed wetlands, but probably the most useful would be according the presence or absence the water on the surface of this constructed wetland. The surface flow constructed wetlands, they can use all types of wetland vegetation. That means emergent plants, submerged plants, free floating plants, and free floating leaf plants. On the other hand, subsurface flow system, because there is no free water on the surface, they use only emergent vegetation. The subsurface flow systems, they can be further classified according the direction of flow, and that's horizontal or vertical. The horizontal flow systems are most commonly continuously fat. That means that the filtration material is constantly filled with water. Therefore, the conditions are mostly anoxic and sometimes even anaerobic, and only small areas around the roots of plants may be aerobic. On the other hand, the vertical flow systems, they are intermittently fat, and each batch of wastewater comes only after the previous batch has percolated through the filter. So for a certain period of time, the filtration bed gets empty, and it's much easier for oxygen to diffuse into the filtration material, and therefore these systems are mostly aerobic and therefore, for example, suitable for nitrification. Sometimes the water can be fat to the bottom, and then the water goes through the filter up, so the filter is more or less filled with the water. So then the condition resembles more as horizontal flow system. As you can see, there is a special group of so-called hybrid constructed wetlands, which are mostly a combination of horizontal and vertical flow systems in order to achieve better removal of total nitrogen. Because horizontal flow systems, which are anoxic or anaerobic, they provide good conditions for denitrification, while vertical flow systems are very good for nitrification. So if we combine them, we can remove total nitrogen. But in general, we can combine, and we will see some pictures in a minute, we can combine all types of constructed wetlands in order to enhance the treatment performance. So let's start with free water surface constructed wetlands. They are usually very shallow trenches with water level between 5 and 40, very commonly only 20 centimeters. There is no special requirement for soils. If soil is present, the major role of the soil is to support the growth of plants. Liner is optional. These systems are usually very large. They move some tens of hectares, even larger. Therefore, the liner would be very expensive. Vegetation is usually not harvested, only if we use free floating plants like lemna or water hyacinth. It's recommended to harvest the plants. Otherwise, in systems with emergent vegetation, the decaying plants may, for example, provide organic carbon for denitrification. In general, these systems, they provide very good removal of organics, suspended solids, and bacteria, but this is more or less the same for all types of constructed wetlands. The major difference is the removal of nitrogen. In these systems, this free water surface, we achieve relatively medium removal of nitrogen, because these systems are mostly aerobic, so we can expect nitrification. If there are algae present, they may increase pH, and also ammonia volatilization may be very effective. And in the layer of decaying plant material, we can expect some denitrification. However, there is usually very low removal of phosphorus, because phosphorus is mostly removed by adsorption and precipitation with aluminum, iron, calcium, or magnesium. And in these systems, there is a relatively very low contact of water and the soil. And the footprint or the area required is usually between 5 and 10 square meters per PE, means per population equivalent. Let's say very simply 5 to 10 meters square per connected person. So few examples. Those are the constructed wetlands with free floating plants. The free floating plants, they do not have any active movement. They are moved by wind or current, and there are two major species which are used. And there are duckweed, lemnaceae, and water hyacinth. Water hyacinth is a very noxious weed in the subtropics and tropics, and the very vigorous growth gives the potential for removal of nutrients, which is true, but the maintenance and operation is a little bit difficult because you keep on harvesting, and more or less the water hyacinth is a waste nobody wants to deal with. So that's a little bit restriction of the use. One restriction is it doesn't survive during the winter in the temperate and cold climate, so it's restricted to subtropics and tropics. And then it creates a lot of waste material during the operation. This is the example of one existing system from Thailand. So you see that the water, it really covers every possible area. So even if you want to prevent the growth, you must create some mechanical fence, otherwise it will overgrow all the water surface. Lemnaceae, duckweeds, very similar, very tiny plants. They are not so sensitive to the temperature. They can easily survive in a very cold climate, and they create the same situation as we have seen for water hyacinth. They completely cover the surface. So that on one side maybe helps to sedimentation of particles, but on the other hand, it prevents the light penetration into the water column. It means it may prevent photosynthesis of algae, which are producers of oxygen. So if this situation lasts some longer time, it may create some anoxic conditions. And as you see, this is the maintenance and operation problems. You also have to harvest the plants quite often in order to allow new plants to grow, and these huge harvesters are necessary to harvest these very tiny plants. So again, maintenance and operation is a little bit more expensive. Then we have another species, water lettuce, and this is the example from Florida, one of the fishing caves on the north side of the Florida Everglades. Again, the very same situation. These free-floating plants, they are the most fastest growing plant on the planet, so they immediately cover the whole surface. Then we have plants with floating leaves. Those are water lilies. There are not so many systems which would use these plants, but there are some. Therefore, I included it in my presentation. So those could be the species: lotus, water lilies, spatterdock, water fringe, Nymphoides peltata, and nice plants. They are very, very ornamental. And here is the example of existing system. This is a very large system, iron bridge, which provides a tertiary treatment for the city of Orlando, 800,000 people. It's quite large system. I think, if I'm correct, maybe 6 square kilometers. It has several cells which are overgrown with different species, and a few cells are, you see, overgrown very heavily with spotted dog, Nufar. Then this is another example. This is from Southeast Asia. Now, the Southeast Asia, they are very much interested, especially in China. They are building hundreds of constructed wetlands. This particular one is to treat stormwater runoff, and the plant which is used is Nelumbo nucifera lotus. Another group are wetlands with submerged plants. Those are plants which are completely submerged in the water. They root in the sediment and they do not grow above the water. That means that they are completely submerged. As you see a few examples: Potamogeton, Myriophyllum, Elodea, Ceratophyllum, very common plants you can use in any other natural wetlands. There are two restrictions or limitations of application. First is the plants grow usually much better in well oxygenated water. Of course, this is not the case of wastewaters. And also the turbidity of the water should be very low, because all the photosynthetic parts are submerged in the water. So the more turbid is the water, the less light penetrates to the plants and it restricts photosynthesis. Therefore, these systems are usually used for tertiary treatment or to treat waters with low concentration of organics, because if you have high concentration of the organics, usually concentration of oxygen is very low. It's very quickly depleted. A few examples, and also as all submerged subjects, also plants are overgrown with periphyton, which is an assemblage which is usually based on algae, and they are very useful because they produce a lot of oxygen. So therefore they help to oxygenate the water. They also take up a lot of nutrients, phosphorus and nitrogen, but because algae are short-lived, so the storage is not a long term, because they die back and nutrients are released back into the water. So it's very short circle. Here is the example of so-called stormwater treatment area north of the Everglades, in between the Florida agriculture area and the Everglades National Park, so-called water conservation areas. And in this region, they are using a lot of these wetlands, which are dominated by submerged, this SAV, submerged aquatic vegetation. In this case, is Ceratophyllum demersum. This is interesting example. This is a circuit of Formula One in Montreal, and they are using also constructed wetlands with submerged vegetation to treat the stormwater runoff from this circuit. Probably the largest group of the constructed wetlands with free water surface are wetlands with emergent vegetation. Those are the most typical wetland plants, like Primaitis, Typha, Carex, Cirpus, Juncus. It's, as I said, it's usually a shallow trench with the water level is between 5 and 40 centimeters, and is very heavily overgrown with wetland vegetation. This is the example from Australia, where they very much use constructed wetlands for tertiary treatment and also for stormwater runoff, because Australia is mostly arid or semi-arid, so they try to use rainwater as much possible, collect it, treat it, and reuse it. So this is the example of this Australian wetland. The next picture shows the system which is in cold climate. It's in Estonia, where the winters are quite cold. So Estonia is more or less about the same latitude as Helsinki or St. Petersburg, so very cold, long winters. Plant is Typha latifolia, and the system has been in operation for more than 15 years, still works very nicely. This is the example from the southern hemisphere. This is the free water surface system is in Otorohanga in New Zealand, in the North Island. And so more or less these, as I said, these systems are very shallow trenches with very dense population of vegetation. You can see a lot of free water that was caused by the geese. They really eat it too much. Recently, there is also another system. There is a so-called constructed wetlands with floating mats of emergent vegetation, because it's a natural process. Sometimes emergent plants, after some disturbance, after some big waves or wind, may be detached and they start to flow. So this is artificially prepared system. And here is the example of such a system from UK. So you fill the trench, and instead of filling it with just water or gravel, you can include this large raft, and the plants are more or less growing from the raft. There's not so many examples at the moment. It's growing experience. So hopefully there will be some, I would say, like guidelines or a recommendation issued soon. These islands could be also smaller ones, and this is an example of from New Zealand. So they're using some styrofoam forms which floating, which are artificially planted with plants and may help to clean the water. So then we are coming to the subsurface flow constructed wetlands. The first large group are those with subsurface horizontal flow, where you can see in the picture that the water, the pre-treated water, is coming to the zone of large stones in order to get good distribution. Then the water flows more or less. This is the ideal situation through the very porous material, usually gravel or crushed rock, is collected at the end of the filtration bed, and using the principle of connected vessels, the water level in the filtration bed can be maintained in the outflow sump. So these systems, they require good mechanical pretreatment in order to remove as much as possible suspended solids, because they can clog the filtration material. They are usually 0.6 to 1 meter deep. They usually use filtration material with very high hydraulic conductivity. The early systems, which were used in Germany and Denmark in late 1970s and early 1980s, they used soil, but soil had on one side that it had a very good treatment efficiency, but the hydraulic conductivity was very low, and the subsurface flow usually switched to surface flow very soon. Those systems are usually always lined, in most cases with plastic liner. The emergent wetland vegetation harvest is optional, but in most cases it's harvested, with the exception of UK, where they never harvest the plants. Otherwise, it's usually harvested. And again, it's very effective for removal of organic suspended solids and compounds which are removed under anoxic or anaerobic condition. That means nitrate and sulfate. And there's a good removal of bacteria and heavy metals. On the other hand, there is usually very low removal of ammonia, because the filtration bed is mostly anoxic, so there is no oxygen enough for nitrification and also for phosphorus, unless special materials are used. This is one of the topics which is now being very intensively searched, and this is the use of filtration materials which would have large sorption capacity. It could be some expanded clay particles, or it could be some waste materials like slags, which are rich in calcium or iron or aluminium. But then we keep in mind that the sorption capacity is always limited, so at certain time it needs to be replaced. But in general, these systems are not used too much useful for removal of phosphorus. So a few examples of the layout. This is the very simple pre-treatment, for example, for a small village. You can see the screens in front, and there is a sand trap or grit chamber, whatever you call it. As I said, the systems are usually lined with plastics, and sometimes they are covered with geotextile in order to provide good protection. Here we see the liner of a small on-site system with a plastic liner, and on the side the geotextile on the right. And you can see this is the a little bit larger installation. On the right side, you see the distribution zone, which is filled with large stones in order to provide good distribution, and then filtration material. This filtration material is usually with the size between 5 and 20 millimeters, and it's recommended to use only one fraction. No layers at all, and even mixing is sometimes not so good, because of course water always try to flow the most easiest way, so then we can get obtain some short circuiting. So the one fraction is best. Then we have the water distribution, which can be done different ways. It's really important to distribute the water across the bed in order to load evenly the whole profile. And also we have some, as I said, mechanisms using which we can maintain the water level. So the lower two pictures are probably the best. It's either flexible hose or plastic pipe hanging on a very easy chain, so you can move it up and down if necessary. So a few examples of the horizontal flow system. This is sorry, this is a small constructed wetland for an on-site treatment for 5 people in the Czech Republic. This is a very special installation because it is in prison in New Zealand. So as I always say, I was there only as a guest. As I was not an inmate, so I spent only a few hours over there. This is the relatively larger system for 25,000 people as a tertiary treatment in South Portugal, in Beja, planted with Phragmites australis. And this is an example of the cold climate system. This is the system in very north Norway, where the average annual temperature slightly above 0. So you can imagine that it's really quite cold, and the system works very nicely throughout the winter. And we have the vertical flow constructed wetlands, which differ from the horizontal ones, of course, because the water flows vertically, so it's brought to the surface and percolates through the filtration layers to the bottom where it is collected. And in difference with vertical flow systems, here we use layers. Usually we use some coarse material on top in order to prevent clogging. The major filtration layer is usually sand, and then we have the drainage layer with larger stones in the bottom. So as I said, they are intermittently fed in order to allow for oxygenation of the bed. We have layers. These systems are a little bit deeper than horizontal flow systems, usually 1 to 1.5 meters. And plants have additional function, as the stems are moved by wind, so that it creates small holes in the surface which allow the water to penetrate into the filtration and also some diffusion of oxygen. Again, a very high removal of organic suspended solids and ammonia. On the other hand, it does not remove any nitrate and sulfate, or very limited amount. I'm not sure if you see the bottom line, but it says that the footprint is between 3 and 4 square meters per person. And I maybe missed it because it was too low for the horizontal flow systems. They are usually 5 square meters per one person. So the vertical flow filters, they usually use a little bit less area. Horizontal flow about 5 meters, vertical flow 3 to 4 meters. Here is the different water distribution. Again, we need to really supply evenly the whole surface, and the best way to actually to flood, very temporarily flood the whole surface, and therefore the distribution of water is very even. If, for example, some of these pipes fail, then we can overload certain part of the filter on the other, and the other part of the filter may not be filled with water at all. Again, a few examples. This is the on-site system in Denmark, in Mørke. The next system is from France. France is probably the country where the vertical flow systems are used most. They have 3 up to 4,000 installation in France, again planted with Phragmites australis. And this is the quite large installation, 25 hectares in China, in South China, near Guangzhou. They have these 8 plants planted at 25 hectares of vertical flow. So even these vertical flow systems can be really very large. Also, there are some attempts to enhance the treatment performance of the systems with using artificial aeration, which of course increase the supply of oxygen, and also the processes are mostly oxic, but it's always the question because the aeration is usually the most expensive part of the wastewater treatment, so we need to calculate if it's really worth to make this installation. One special example is so-called zero discharge willow constructed wetland in Denmark. They are mostly built in Denmark. There are several thousand installations. They are relatively large. This is for one farmhouse, maybe 200 to 300 square meters. It's planted with willow, Salix verminalis, and this plant has a very high rate of evapotranspiration. And the principle is that during the winter time, when there is no evapotranspiration, which in Denmark is no evapotranspiration between November and about March, so the filtration bed is slowly filling with wastewater and the rainwater. However, during the growing season, the evapotranspiration is higher than the inflow, and the water actually goes down. So there is no outflow. So it's very, very good that you don't need to deal with discharge limits because there is no discharge. And so we have the hybrid constructed wetlands, which I have already said, they were mostly created in order to enhance treatment performance, and especially for nitrogen, because as we know, the nitrification and denitrification, these processes proceed under different redox conditions, and it's very difficult to provide both these conditions in one bed. Therefore, we have one system for nitrification and the second for denitrification. This system is relatively old because it has been suggested only in the very early 1960s in Germany by Dr. Seidel. Therefore, these systems are sometimes called Seidel system. And they usually have several vertical flow beds which were used in rotation, like 1 week each. And then there was a series of horizontal beds, and the idea was to achieve nitrification in the vertical flow beds and denitrification in the horizontal flow beds. Here are a few examples of this system. This is the original system designed by Seidel in Germany. This is a similar system in Slovenia, 2 vertical flows followed by a horizontal flow system. And in the late 1990s, the Danish colleagues came with another idea, more or less the other way around. So they use the first stage, horizontal flow, and the second is vertical flow. And the idea is to remove organics and suspended solids in the horizontal flow bed and to achieve nitrification in the second bed. So we have the outflow, which is very low in organics and very high in nitrate, and therefore the water is recycled to the inflow. So we have very high concentration of nitrate, and we have the organics coming from the raw wastewater. So the denitrification is achieved in the horizontal flow bed. Here is the system. This is very well studied systems in Denmark. And few examples of these hybrid systems which combine different systems. This is in Yanshan in China. It's a very old picture from 1994 where they combine water hyacinth cells and the subsurface flow system planted with Phragmites. This is a kind of experimental system from Estonia where they combine everything: vertical flow, horizontal flow, free water surface, and pond. It's a very small village for about 300 people, so it was really kind of like an experimental system. And this is a combination of free water surface and vertical flow system in China. Again, you see that in China, there's quite a few systems are very large. This is nearly 6 hectares. For European scale. It would be really extremely high. For China, it's relatively small, small wetland. And on the upper right corner, you see the sprinklers which distribute the wastewater in the vertical flow systems. So in general, the removal efficiency is very high for organics and suspended solids in all types of constructed wetlands. In terms of ammonia, it's very high in vertical flow systems, moderate in free water surface, and very low in horizontal flow systems because of the lack of oxygen. The removal of nitrate is the other way around. So we have the high in horizontal flow and low in vertical flow system, and we still achieve some moderate removal in free water surface. In terms of total nitrogen, we can see that it's moderate in all single systems, but can be enhanced in hybrid constructed wetlands. Concerning phosphorus, it's usually quite low unless we use special filtration material. Bacteria is usually very high, and it's partially because there is usually long retention time, and the bacteria are not under favorable conditions, and also plants they release some antibacterial exudate. So the removal is usually quite good. And now the short part on the types of wastewaters which are used in constructed wetlands. So still the majority constructed wetlands is treating municipal sewage, both separate or combined. Combined means it's combined with stormwater runoff. There is good use for agriculture treatment. That means usually for the feedlots. And we have quite a large use for industrial purposes, mine drainage. It could be coal or metals. It's a very large group of food processing wastewaters, which are characterized with very high concentrations of organics, but usually very well biodegradable. It's sugars, alcohols, and so on. But we can use them also for heavy industry like pulp and paper, fertilizers, oil refineries. There is a very good use for runoff water. Stormwater runoff from cities, urban, highway, airports during the winter, field crop, nursery, greenhouse. And also there is not much seen, but believe me, there is landfill leachate. It's also another category, and sludge stabilization. So very quickly, a few examples how these wetlands may work. So this is the so-called integrated constructed wetland for farmyard runoff in Ireland. You can see there's 1, 2, 3, 4, 5 cells. On the left side, there is a creek where the water is discharged. This is the treatment of mine drainage. Mine drainage is usually acid because it's usually coal is very often found together with pyrite, Fs2. So then we have a lot of sulfuric acid and a lot of sulfate and iron. But sometimes the sulfur is also together with calcium carbonate, and then we have the alkaline water. So this is the example. Mostly Typha is used because it is very tolerant to pH. These alkaline waters are not extremely alkaline. They may have like pH 9, but the acid drainage water may have pH 2 or 2.5. But it's extremely low pHs. This is the example of the treatment of the soft drink production of wastewaters from Uruguay. The soft drink production wastewaters are very rich in sugars. So that's may have very high, several thousand, even tens of thousands of milligrams per liter BOD and COD. This is an example of the hybrid constructed wetland for winery treatment. The use of constructed wetlands for winery wastewaters is relatively new and is mostly done in countries which produce a lot of wine, of course. So it's Italy, Spain, California, Australia, South Africa. these countries, they are very much involved in this treatment. This is a combination of horizontal flow and free water surface. This is the horizontal flow bed, very typical, planted with Phragmites, and also we have free water surface, anything special, just a combination of the horizontal flow and free water surface system. This is the wastewater treatment from Canada. Also, it's quite cold region for treating of abattoir or slaughterhouse wastewaters, which are usually very rich in BOD and COD because there is a lot of blood presented in the water. This is the pulp and paper wastewater, free water surface systems in Florida. Also, very old picture from 1991. So I'm not sure if the treatment system is still there, but hopefully yes. Here is the example of industrial wastewater treatment. This is one of the largest chemical companies in Europe providing nitric acid in Portugal. So they can see that the horizontal flow systems, which are very good for denitrification, they manage to decrease the nitrate concentration from 600 to only 9 milligrams per liter. This is an example of the stormwater runoff from the urban areas. This is from Australia, Plumpton Park in Sydney. So as I said, there's a lot of interest in harvesting, as they say, harvesting rainwater. So this is the quite large system which treats. This is, I think, very neat example of the wetland which treats stormwater runoff from a parking lot. If you take a look at the pictures, that's on the right side is a very large parking lot in front of the Walmart in Charleston, South Carolina. And during the rain, the water is coming from these pipes to this small valley and then flows through the Taifa-based constructed wetland. I think it's a very nice example how we can use wetlands in the cities also. This is another, I think, nice installation, and it's getting more and more common. It's a constructed wetlands which treat rainwater runoff from golf courses, because of course these runoffs are quite rich in nutrients because the golf courses are very heavily fertilized. There are also quite heavy use of pesticides, and also sometimes you can find some dyes because, as you all know, the final part of the hole is so-called green, and it must be green. It's sometimes painted by green paint and it's washed out. So this is the water goes into this constructed wetland. It also serves like a kind of a bunker, and then it's used for irrigation of the golf course. Next example is from New Zealand. New Zealand researchers, they have spent a lot of effort in developing guidelines for treatment of tile drainage, because there is a large part of the country are pastures which are quite heavily fertilized, so they have a problem with nitrate. So you see there is a drainage ditch coming from the top of the picture, and then water is diverted through the wetland, free water surface, and it goes back into the ditch. And here are some numbers. So we can remove more than 800 kilograms nitrogen per hectare per year. So it's relatively very large efficiency. This is the example of the treatment of airport runoff, because especially in cold climates, the airports sometimes during the winter when planes are waiting for the takeoff, they are sprayed with liquids, this anti-freezing and de-icing liquids, in order to keep all the wings and tails in proper function. These waters are usually very rich in organics, anti-freezing organics, so they can have up to like 200,000 COD or so. So this is the example of the Buffalo Niagara Airport, which is more or less very cold for, I don't know, 5 or 6 months. Here you can see the example how this is I guess from the Prague airport, that the aircraft is being de-iced before the takeoff. So it takes a large volume of water, which is very rich in organics. Slowly getting to the close, landfill leachate. Landfill leachate is very difficult wastewater. If sometimes it's not even classified as a wastewater, is a simply landfill leachate. As I usually say, it contains anything you can imagine. You can have very high concentration of BOD, COD, ammonia, trace organics, heavy metals. Usually lower concentrations of phosphorus, but anyway, still it's usually bad smelling liquid, very colorful. And few examples of so this is the system which was designed in Portugal. So they use inflow goes into the lagoons, then the water goes through the vertical flow and the horizontal flow constructed wetland. This is another very old system, also from 1991 in Pensacola, Florida, is a treatment which is treated in constructed wetlands. So you see that there's really wide variety of wastewaters which can be treated in constructed wetlands. And I think that at the moment we can see that constructed wetlands can be used for any type of wastewaters. Yeah, this is quite common. Question is how these constructed wetlands, especially those, for example, on-site systems, how they deal with surfactants and detergents which are used in the households. So the answer will be they deal it quite nicely, easily, and this is the example from Australia, where the constructed wetland was designed to treat wastewaters from a commercial laundry. So it's the answer is that these systems can handle that very nicely. And that will be it for today. Thank you very much for your attention. And if you have any questions, I will be happy to answer them if I know the answer.
Thank you so much, Jan. We will now begin the question portion. So it looks like we already have some questions that have come in. So please type in your questions as you think of them, but we'll start with some that were asked during the presentation. And just as a side note, while we're waiting for some more questions to come in, some attendees had mentioned that they had some difficulty accessing the PDF copy of the slides. If you would like a copy of these slides, please email membership@sws.org, and we'll make sure to email you a copy. So here we begin with the very first question. This is from Walker Wilson. And Walker asked, I see a lot of exotic species being used. Is there any effort to select native species, or is it simply easier to use proven exotics?
Well, of course, I know that especially in the United States, they are very strict in exotic or invasive species, so it's not recommended to use, for example, Phragmites australis, the same is in New Zealand, but otherwise in other types, in other parts of the world, like in China or Europe, we are not so strict, but in general, the traditional plant which is used in all types of constructed wetlands is Phragmites australis. Of course, this is a problem in the United States. I can understand that. But of course, they could be used some native plants as well. The very common plants, for example, in Europe is Phalaris aruninacea, reed canary grass, which of course is very invasive in Wisconsin, for example. So but you can use Typha or Cirpus. Of course, the local plants, it's generally agreed that the plants, they help to create conditions which are suitable for pollution removal. And there have been many attempts to find out if some species are more effective or less effective. And it has been found that in general, the presence of plants is beneficial, no doubt about that. But there is not much difference in the species themselves. So it's definitely not necessary to use exotic species.
Okay, thank you, Jan. We had an attendee also say during the answer for that question that they can provide the questionnaire a list of native and naturalized species they have grown in a constructed wetland in Idaho. So perhaps the questioner, if you're interested, if you could just put your email in the chat window, then maybe they could send that to you. Continuing on, the next question we have is, Jan, could you repeat what the abbreviation PE stands for again?
Yes, it's the PE stands as a personal equivalent and is derived on the unit 60 grams of BOD per person per day. So it's a number which may differ among countries, but in general, it is known that I would say in developed world, usually one person produces about 60 grams BOD per person per day, and that's the PE. So it's more or less, we can say, connected people also, because when we do the design, the population equivalent is equal to number of connected people. But if we, for example, try to recalculate the industrial wastewaters, then we have to use this unit, which is 60 grams. So, for example, if we have a concentration, or if we have the production of I don't know, let's say 600 grams BOD, so it equals 10 people.
Okay, thank you, Jan. The next question we have from Jody Murray Burns is, when constructed wetlands are used to treat heavy metals, is there a tipping point where the vegetation used has to be harvested or removed because of negative effects to plant growth? If so, what is usually done with the plant material that is hauled off?
Yes, I have personally done a lot of research on these heavy metals in constructed wetlands, and we found, and it's only not our experience, but most heavy metals are actually fixed in the sediment. And for example, in these horizontal flow systems, which are usually anaerobic or anoxic, they usually are fixed by sulfides, because sulfate is reduced to hydrogen sulfide, which very quickly reacts with heavy metals, and it stays in the sediment. And we have a very good results that, for example, out of removed heavy metals, it goes like 5 to 10% only goes into the above ground biomass. So the concentrations in the above ground biomass of heavy metals is usually slightly higher than in natural stands. Of course, if we deal with, let's say, municipal wastewaters, maybe a different story can be if we treat industrial wastewaters. But anyway, the majority of heavy metal stays in the filtration bed.
Okay. Moving on to the next question, also from Jody Murray Burns, we have, what differences in the design of constructed wetlands do you usually see when working in karst areas? And for listeners, that is landscapes that are underlain with limestone and are experiencing erosion.
Well, there are not so many constructed wetlands in this area. I'm aware of these systems in Slovenia because they have a very large karstic areas. Of course, that's need to be probably very careful research or survey before the constructed wetland is designed. And of course, it also depends on the on the level of the groundwater and so on. So I think it's very difficult to say any general rule how to deal with that. It needs to be probably solved according to local conditions. But
Okay.
as I said, there are really, I'm not aware of many constructed wetlands which would be in karstic area. There are some in Slovenia, but they are quite small.
Okay, thank you. The next question is actually from Rob Tiedemann. He was actually asking Jan if you could provide some references maybe to him for in the literature for the cold climate constructed wetlands. So perhaps that could be sent out later after today. That could be sent out to the attendees.
Yes, I put my email on the chat chapter, so it should be accessible. I do have, there is actually very good book, which I think was published 2002. It says the constructed wetland in cold climate, and there are good examples from Sweden, Estonia, Canada, Minnesota. So it's a good book, but I can provide some papers as well. So feel free to send me the email and I will reply.
Okay. Next question is from Katie Goff, and she is wondering, what are some methods for increasing nitrate removal efficiency in constructed wetlands?
Yes, I said it depends what species of nitrogen we have in the wastewater. So of course we in a municipal wastewater, the majority of nitrogen is either in as ammonia or organic nitrogen, which is converted always into ammonia. So then also it depends what would be the requirement for the discharge. So as I said, the vertical flow systems are very effective in removal of ammonia, but vertical flow systems themselves, they just converted it into nitrate. On the other hand, horizontal flow systems are very good in removing nitrate. So probably the best way how we can remove the total nitrogen, that means both nitrate and ammonia, is a combination of horizontal and vertical flow.
Okay. The next question is from Michelle Simoneau. What considerations are given to many of the plants that are aggressively invasive in many areas? Are there specific recommendations based on ecoregions?
Well, I think that this is a special situation for the United States, because most plants which are commonly used in Europe, for example, it's Phragmites, Phalaris, Typha, Carex, Cirpus, they are not considered as aggressive or invasive. They are native species, and we on the other hand try to save Phragmites. So I don't have much experience with this, because we really are more or less not restricted, because most invasive species which are especially in the Central Europe, they are terrestrial. We don't have many really invasive aquatic or wetland species. So this would probably mostly concern the United States. And I know every state has the list of invasive species and a list of this obligatory wetland species all the way to the obligatory terrestrial species. So of course they are not used. So it will probably depend on each state and what are the state's permits and regulations. But as I said, the plants are important, but species is not as important. So if you use some other species, some local species, that's fine.
Okay. The next question is from Hector, and he is asking, do you know if somebody tried to combine this kind of system with forage producing systems and also with carbon capture systems? Did they have good results?
Well, it's not much actually studied. there have been a lot of measurements on the release of greenhouse gases from constructed wetlands, but in my opinion, there is a much higher sequestration of carbon because these plants are very productive. So both for nitrogen and carbon, there is the constructed wetlands are for sure a sink. There is still not so much multi-function constructed wetlands which are designed for wastewater treatment. For example, in Sweden, they start to, besides wastewater treatment, is the biodiversity. So they try to plant different species, and of course, if the systems are large, then you can also provide some wildlife habitat. But if you have a very small constructed wetland, like 100 square meters, probably would not expect too much wildlife habitat. But there is still, I think, large gap in creating or design wetlands with multi-function purposes. Let's say if you have a first major purpose is wastewater treatment, so there is still not much other benefits which we focus on. It's still a gap.
Okay. The next question, and also just we're a bit over 2 o'clock, but Jan and I both said that we would like to stay on to answer some of these questions. So we thank you for staying with us. We have some good questions coming up. The next one is from Barry Black, and the question is, what are the risks involved with creating an attractive nuisance that might create other biological problems in a large, mature, fabricated system?
Well, I'm not sure if I understand the question. Let's say, can you just
maybe you can specify a little bit. Itself? We'll go to another one and see if that one gets specified a little bit. Let me see. So the next question is, what are the maintenance requirements of the FWS wetlands and the horizontal vertical flow wetlands?
Well, the major maintenance must deal with the pretreatment because it's quite important. We have to remove as much as possible suspended solids. And if we don't clean these systems regularly, then because these systems may get anaerobic, and during the anaerobic conditions, a lot of gases are formed like CO2, H2S, methane, nitrogen, and the bubbles, they actually floatate the sedimented material, and then it flows into the constructed wetlands. In horizontal flow systems, well, then we may clog it, so we can experience more surface flow, which is not a complete disaster. It's still working, but for vertical flow, it's a problem because if you clog the surface, then the water has no way to percolate. So the major maintenance is always dealing with pretreatment. Concerning the constructed wetland itself, it's just more or less a regular check if the water is evenly distributed, if the outflow level is set at the desirable height, and also I think it's beneficial if we remove the plants, because if we don't remove plants at all, of course, after the biomass decay, it will be slowly humidified and will convert it into soil. And especially into these subsurface flow systems, the soil is usually very loose. So when, for example, when it's raining, or in a vertical flow system, when you add the water to the surface, you may actually wash the soil into the filter, and then you may get much faster clogging of the system.
Okay. Now I'm going to try to piece together Barry's response to our question to him. So the first question again was, what are the risks involved with creating an attractive nuisance that might create other biological problems in a large, mature, fabricated ecosystem? And then he specified, after we asked, for example, in a system where sediments become a problem from ingestion from wildlife, what down the road problems might be encountered?
Well, uh, this probably deals with a very large system, but of course, as I mentioned, there are some systems which may be 20 hectares. And so I was 2 weeks ago, I was in China, and they plan to do constructed wetlands with the size of 1 square kilometer. So it's really very large wetland, and then you expect maybe some interaction with wildlife. But I haven't heard so far any examples of the really problems which would be caused by the wildlife. There are some problems, for example, where the rabbits or goose or ducks, they eat the plants, but this is nothing that would really uh, completely kill the system. So, of course, if you create a very large system, but these systems are sometimes called engineered, but the engineering is really low level. It's just we recommend, and in most countries, the more simple the design is, the better. So we try to stay away of very complicated structures. So they, as I remember exactly, Bill Mitch in 1992, in the first issue of the Ecological Engineering, when he was talking about constructed wetlands, his one of the major points was, do not over-engineer these systems. So that's, even after 25 years, it's true. So these systems try to be very natural, and also then the problems which are there are more or less natural as well. So I wouldn't worry about some extreme problems which would be caused by these engineered systems.
Okay. Just a quick side note, some attendees are asking about the comment window. I just opened it to the entire audience. That may or may not have worked. So if you go into chat, I sent out Jan's email. If it's not there, we can always just send out an email to you all collectively at the end. I think we have time for one more question. This one is from Latoya Kasoon Charles. What is usually done with free-floating harvested plant material like lemna that is collected after treatment of various wastewaters? For example, wastewaters contaminated with metals.
Well, I said the lemna is, of course, takes up a lot of nutrients and heavy metals as well, and the harvesting and following maintenance is always the problem. And in water hyacinth, it's usually wasted. So I'm not sure what they use. It's actually not so many systems in operation at the moment. There was a very high expectations in the 1970s and early 1980s. There's a lot of papers from southern states of the United States, like Florida, Alabama, Texas, on these water hyacinth constructed wetlands, and it turned out that there was a waste. So I'm afraid that even the lemna, which would be contaminated with heavy metals, must be probably landfilled, or I don't know.
Okay. All right, everyone. There are still a couple more questions left, but I will forward those to Jan so he can maybe answer them via email. If your question did not get answered, if you could just send your email address in the question window so he can get back to you if you would like to hear from him.
Yeah, I put my email there, so hopefully people will email me their questions, and I will be happy to answer them if I know the answer.
Yeah, that's probably the best way to do it. So yes, his email is there. If you can't see that, like I said, we'll send it to the attendees so that they have it. All right, so we just have a couple little business items to close out our webinar. So please mark your calendars for our next webinar. The August webinar will be on Thursday, August 17th at 1 p.m. Eastern. We hope to see you there. We're always looking for future webinar presenters and topics. So if you yourself are interested in presenting an SWS webinar, or if you have a topic of interest that you would like to see us cover, please indicate this in the evaluation survey that you will receive after the conclusion of this webinar, or contact SWS headquarters. In addition, please consider taking a short 10-minute survey accessible by the link on the screen in our follow-up email to help us improve this series even further. The SWS Webinar Committee continuously strives to enhance the value of the SWS Webinar series as a membership benefit. Responses are confidential and will be collected until July 31st. Thank you in advance for your participation and for supporting the SWS Webinar series. Also, it's never too early to save the date. Join us May 29th through June 1st, 2018 in Denver, Colorado, USA for the 2018 SWS Annual Meeting, Wetland Science Integrating Research, Practice, and Policy, and Exchange of Expertise. Lastly, thank you, Jan, for taking time out of your busy schedule to present an SWS webinar. And thanks to our audience for attending today and for contributing to great discussion. We hope you can all join us for the upcoming webinar in August. Thanks, everyone, and have a great rest of your day.